In examples 1C and 1D, the relationships that we have been given are different from the relationships in examples 1A and 1B. So here in 1C and 1D, we have been given a list of ordered pairs. So let's take a look at what we have here. Each one of these guys is an XY pair, like I said. Okay, so for this first ordered pair in example 1C 2, 6, the way you want to interpret that, that is the point 2, 6, meaning if I'm going to go ahead and plot these points for you. Okay, you don't have to do that to determine whether or not this is a function, but I want you to be able to understand what you have been given. Okay, so if you plotted these points, so we've done some graphing already in this class. So if we draw in our x-axis and then we come in with the y-axis, this first point that we have been given is the ordered pair 2, 6. Okay, so that means if the x coordinate is 2, then the y coordinate would be 6. And we would be talking about this particular point right here. Okay, so that's that first ordered pair. And then if you moved on to the second ordered pair, again, you have an XY pair. So this time, if x is -3 and y is 6, okay, that would be this point. Okay, and then you could plot the other two if you wanted to. You don't have to if you're just trying to determine whether this relationship that you've been given defines a function or not. Okay, I just graphed or started graphing these ordered pairs out just so you can tell what you're dealing with here. You're dealing with a set of ordered pairs or points in the plane. Okay, so the question is, again, is this a function? Okay, so what you can do here to determine this, you can actually make it look like what we saw in examples 1A and 1B with the arrow diagram. Okay, so let's talk about how you would convert this into an arrow diagram. Okay, what you're going to do, you're going to make a column for your x values and for your y values. And what we've talked about already, x represents our inputs, and then the y values are going to be our outputs. Okay, so what I'm going to do, instead of like going point by point and putting this in the diagram here, I am going to take a look at the x values first, all the inputs. So I've got 2, -3, 4, and 2. Okay, so I'm going to make my input column first, and to make this very readable, I want to arrange these inputs in ascending order. And if you notice, 2 is appearing twice. We have 2, 6 and 2, 10. So 2 appears twice as an input. Do not write duplicates. We only need to write 2 one time. It makes it harder to interpret if you write it more than once. Okay, so here we go. For our inputs, I have -3, 2, and 4. Okay, that's what I want to write down. Okay, again, we need them in ascending order, and we don't write anything that appears more than once. We don't write it more than once. Okay, we're going to do the same thing for our outputs. Okay, so for the y values here, we've got 6, 6, 9, and 10. We want them in ascending order. 6 is duplicated here, but we're only going to write it one time. So we've got 6, 9, and 10. All right, so now we've got our input column, we've got our output column. We're going to define the relationship by drawing arrows. Okay, we want to draw from the input to the output according to each ordered pair. So looking at this first ordered pair, 2, 6, that is telling us that we need to draw from 2 to 6. Okay, so this is how we're going to draw our arrow here. Okay, if we move on to the next ordered pair, -3, 6. That means an input of -3 gives us an output of 6. Okay, so I need to draw the arrow here from -3 to 6. Okay, and then let's jump to the next ordered pair, which is 4, 9. Okay, so this time we need to draw an arrow from 4 to 9. And then lastly, we have the ordered pair 2, 10. So that means that an input of 2 is going to give us an output of 10. So we need to draw from 2 to 10. Okay, so this is how you can make it very similar. You can make some relationship like this look very readable, just like it was very readable in examples 1A and 1B. Make yourself an arrow diagram. Okay, now to determine whether or not this relationship is a function, you need to ask yourself that question: does every input have a single output? Okay, -3, our first input, it has a single output, 6. Okay, but then here comes the problem. The input of 2, it has 2 different outputs. 2 is mapped to both 6 and to 10. Okay, so that's a problem. Okay, so we're going to say this is not a function because x equals 2 has 2 different outputs. Namely, y equals 6 and y equals 10. Okay, so there we go. Now, you did not have to make the arrow diagram if you didn't want to. You could have looked at this and said, okay, I see 2 twice as an input and it's got 2 different outputs. Okay, it's just a matter of how you like to interpret this. Okay, all right, even though this is not a function, we do need to write down the domain and the range. Okay, so let's start with the domain. So you are going to write down your inputs. Okay, here you have 3 different inputs: -3, +2, and +4. Okay, so we're going to list them out. So -3, 2, 4, separate them with commas. And since it's just those 3 inputs, we're going to put curly braces around them. Okay, if you had written this -3 to 4, okay, with parentheses around it, this is incorrect. This means all numbers between -3 and 4. Okay, so you cannot write it that way. You don't want to pick up every single number between -3 and +4. Okay, 1 is not an input, 0 is not an input, for example, so you definitely don't want to do that. Same thing with brackets. That's also incorrect to do. Okay, you have just 3 inputs, okay, and you want to list them out and then enclose them in braces. Okay, the range is going to be very similar. It's all the outputs or the y values here. We have 3 outputs, 6, 9, and 10. List them, separate them with commas, put them in curly braces. Okay, that's it. Okay, let's move on to the next relationship. Okay, again, we've got a set of ordered pairs. We need to determine whether or not this represents a function. Okay, so again, I'm going to make my columns here, my x values and my y values. I think this is just a very visual way of looking at it. So x is going to represent all your inputs, your y values are going to be your outputs. So let's take a look at the inputs first. We've got 1, 2, 3, and 4. So those are our x values. There aren't any repeated ones here. I am just going to list them out in ascending order. And then I'm going to turn to the y values here. Every input has the same y value. Okay, so I've got 3 as my output, and I don't need to duplicate it. It's going to make it harder to read if you duplicate it. Okay, so now we need to go to each input and draw to the output. Okay, so for the first ordered pair, 1, 3, we need to draw an arrow from 1 to 3. And then we need to draw the next ordered pair in. So 2, 3, we're going to draw from 2 to 3. And then we're going to draw from 3 to 3 to represent the ordered pair, 3, 3. And then lastly, to represent 4, 3, we're going to draw from the input of 4 to the output of 3. Okay, so this is what your arrow diagram looks like. Every input has the same output. Is this a function? Well, does every input have a single output? Yes. 1 has a single output, 3. 2 has a single output, 3. 3 has a single output, 3. 4 has a single output, 3. It's okay that they all have the same output. What matters here is that every input has 1 output. Okay, so this is a function. And we're going to write because every input has a single output. All right, we need to list out the domain and range. Okay, domain, again, just our inputs. We have 4 different inputs. That's it. Okay, so we need to list them 1, 2, 3, and 4, separate them with commas, enclose the whole list in braces. Okay, the range is all the outputs. We only get one number as an output, which is 3, and that's it. That's the only number to list. Enclose it in curly braces. Done.